Okay, it's recording. I need to make sure because I have been having a lot of issues with the recording. I'd like to start off by saying that I think I finally worked out the recordings and the extracurricular activities. So I have actually created a YouTube channel to put these recordings on. And after class, I will be putting the YouTube channel in the WhatsApp group. And I think I will finally be assigning just a little bit of work to be doing during the week. It's just a few simple simple things on a website, just so I could see how you guys are doing in math right now. But to start on with the lesson, it is 1 o'clock. So last time we talked about geometry and shapes and perimeter and area.
Sir, I was not here last week. Can you please give me a summary of what happened last week?
Yes, very good. I'm sorry, I unfortunately did not put out the recording just yet. I've been having a couple issues with it. All right, so we went over geometry last week and we covered perimeter, and area and shapes. Miss Delana. Miss Delana, glad you could join. We are covering that. We are reviewing a little bit of what we did last week, and I have said to everybody so far that I have created a YouTube channel to put on the recordings on, and I will put it in the chat afterwards. So last week we talked about geometry, and in it we covered perimeter and area. Perimeter, we said, no, not there. So we said perimeter Who was here last week? Miss Alicia, you were here. Can you recall what perimeter means? Miss Alicia, can you hear?
Length times width times 2 plus 2.
Well, Mrs. Alicia has said length times width. This is not, in fact, perimeter. Mr. Deo-chan, I believe you were also here last week. Could you tell us what is length times width referring to?
It's area, sir.
Very good. Length times width refers to area. Length times width is how you calculate area. And Mr. Deo-chan, if this is area, could you tell us what is area?
Area is a space occupied in a shape.
Very good. So the area is the flat space that a shape takes up. Any questions so far? Very good. The way that we describe space is by a measurement. Now, area refers to length times width. And a flat shape is two-dimensional, so it goes up and it goes to the side. So we cannot say that the area of a shape is 6 meters, because 6 meters describes a length. So the way we write it is 6 meters square. And 6 meters square describes how long the shape is and how tall the shape is. Whereas if we had one square that was 1 meter by 1 meter, you could fit 6 of these squares inside of an area of 6 meters squared. Does anyone not understand anything so far?
Yes, sir. Can you please repeat that? I have a bad Wi-Fi connection.
Very good. This is an issue that we've been trying to deal with for a while. So when we describe the length of an object or how much space something takes up, we use things like meters and centimeters. And meters and centimeters tells us our length. However, we cannot say how much space a shape takes up because a shape does not describe a length. So we describe a shape in meters squared. So a meter times a meter. That's why we're using length times width. So this square, notice how we're using 6 square meters. So a square is 1 meter by 1 meter in this instance, an area of 1 meter squared. And this value of 6 meters squared says that in an area of 6 meters squared, we can fit 6 of these 1 meter squared squares. Does that make sense?
Yes, sir.
Yeah.
Okay. Any questions so far? Okay. So this describes area, the amount of space that a shape takes up. This is the main thing that we're looking at so far. Does anybody know what perimeter is?
Perimeter is length plus width times 2.
Perimeter is distance around an object.
Both of those are technically true in a sense. So perimeter, let's erase this for the time being. So perimeter describes the length around a shape. Okay. Sorry. So what this means is that in the instance of a square meter, meter squared, in the example that we used before, we said that the sides of it are meter by meter. So since we said a perimeter is the length around a shape, that means from here, the perimeter would describe how much distance we would travel if we were to go all around the square. Could anybody tell me what the perimeter of this square would be and why? Very well. Earlier, someone gave us an example of perimeter. They said length plus width times 2. This is true when it comes to a shape or a square or a rectangle, because we have the length of the rectangle plus the width of the rectangle. So that would make one side, that would make 2 sides of the square. So this half of the square here. And since we multiply it by 2, that covers the other half of the square. Mr. Nathan, glad you could rejoin us. We are simply...
Sorry for the connection, sir.
You're perfectly fine. We are just reviewing perimeter and area. So this equation, length plus width times 2, this covers both lengths and both widths, because it would describe the length plus the length plus the width plus the width. And since each side of the square is the same and each side is 1 meter, since there are 4 sides of the square and you add all of them together, that comes out to 4 meters. And I want you to notice that 4 meters is different from how we write the area of meter squared, because meter by itself describes a length as opposed to an area, as we wrote in meters squared. So since this describes a length of, let's say, this line of 4 meters, this line is long enough that if you bend it, that it perfectly forms the outside of this square. Any questions so far?
Sorry, sir, my internet is really bad. I didn't get any of it.
That's perfectly fine. So since the perimeter is the outside of the whole shape, we can say that the distance that we would travel around the whole square is the same as all the sides of the square added together. So since the square is 1 meter by 1 meter, we add 1 meter 4 times for all the sides of the square, which comes up to 4 meters, which describes the length of a line that if you bend it, makes the outline of the whole square. Did you hear that?
Yes, sir.
Yeah, I got most of it.
Okay, very good. So that describes perimeter. Perimeter is very simple. It is just the outline of the whole shape. Area is more complicated. And to elaborate on this, we need to talk about other shapes. So we all know our shapes. Can you call out some shapes? Anyone?
A square.
Okay, square. Square, and then
Triangle.
triangle, perfect. And of course, circle. These are regular shapes. And they are called regular shapes because they are perfect shapes, at least how we have them. So a circle is always exactly round, so it is regular. A square always has equal sides, so that's regular. A regular triangle is when all 3 of the sides are the same. Any other shape is simply a regular, is simply a shape. We do not say that it is regular. So this can be any 2-dimensional figure that is closed. So this is a shape just as much as this is a shape. It's just that this one is curved and this one is a right triangle. I want you to note that perimeter is the same for both of these. You find it by the length of this entire outside. So in the right triangle, you would add up all three of the sides. With this nasty shape, you would have to somehow find the length of the entire outline. One thing that we talked about before is that with all shapes, aside from the circle and curved objects, every single shape that only has flat sides, such as this, can be broken up into triangles. So triangles are the most important shape you'll need to learn. That's why there's an entire math class that you will have to go through called trigonometry, where trig means triangle and metry means measurement. So the entire class is based off of the measurement of triangles. So to show this, we have our square, which we can cut in half to make a perfect triangle. Or not a perfect triangle, a right triangle. And we can see that the square becomes two right triangles. We can do this again and so forth, and we get only triangles. If we do this with a different shape, let's say a hexagon, which was a problem that we did in the last class. If we divide it up into its corners, it is built up of 6 perfect triangles. And if we go back to the weird shape I drew before, you divide up this shape into a rectangle and 2 triangles. And this would be known as a trapezoid. Any questions so far? Okay.
Sir,
Yes.
for perimeter, you can also just add the different measurements on each side, especially if it's an irregular shape.
Yes. So when you're finding perimeter and area, if they give you information, you'll use that information to add it all up to find the perimeter. Or if they break the shapes down for you already, you can add them up to find the area. But for the purpose of in the future, when they give us the minimum amount of information to solve a problem, we will have to apply our knowledge of geometry to figure out what the area and perimeter will be. Did that answer your question well? Or your point?
Yes, sir.
Very good. So, when we describe the area of a shape, we don't need to worry about perimeter because perimeter will be needed to give it to us by what information they give us on the page. So if they have a square that tells us what one side of the square is, you have to use that to find the perimeter. But to find area, it is more complicated. You will need to break up shapes into smaller parts, ideally triangles, if it only has flat sides. Such as the square, for instance, since the square is cut in half, what is the area of a square? Can anybody remind me? Area of a square.
Length times width.
Length times width, perfect. Length times width. In the instance of a square, specifically, because the square, for squares specifically, squares, all sides of the square are the same because it is a regular shape. Because of that, the length and width are the same. So the area is also equal to the length squared. That's why they call it squared. I went into a rant in the last class about how most to all forms of algebra, geometry, and math so forward are merely expressions of geometry, and that's why they call this length squared. But when we find the area of a square, it is length times width. Does anybody know what the area of a triangle is? Very well. The area of a triangle is 1/2 length times width. Does anybody see a connection? I need to ask if everybody can hear and see me well.
Yes, sir.
Okay,
You're breaking up a bit for me.
okay,
On the
Yes,
video
sir. I can't
also.
really hear you that good.
okay. So it seems I'm having a little bit of connection issues as well. Does everybody see that the area of a triangle is 1/2 length times width?
Yes, sir.
Yes, sir.
Okay. Does anybody see a connection? Very well. I told you before that when we find the areas of shapes, we particularly like to use triangles. As we can see here, the area of Good afternoon, Miss Ariel and Mr. Arian, I presume. We are talking about, we are reviewing geometry, perimeter, and area from last class. And I just noted that this area of a square is length times, what's that? Miss Delana. I was noting that the area of a square is length times width, and the area of a triangle is 1/2 length times width. I demonstrated this by drawing a square and expressing the square in terms of triangles, where I cut the square in half, and we can see that the square is built up of 2 triangles. And if we were to find the area of the whole square using the triangles, we would see both of these triangles are the same because the square is regular and I cut it perfectly in half. So the area of a square is equal to 2 triangles of an area of 1/2 length times width, or in other words, 1/2 base times height. As you can see here, the area of a square is denoted from adding 2 triangles together, where you have 2 times 1/2 length times width, or in other words, base times height. Mrs. Marks, I'm glad you could reconnect. We said that because a square is built up of 2 triangles, and the triangle's area is 1/2 length times width, 2 times the area of the triangle is equal to the square, because the square is built up of 2 triangles. Does anybody have any questions? Very well. From now on, I will be tending to use, no, not base. I will be using length and height more often than not. There's not many times where you would use width in discussion. You would be saying side 1, side 2, etc., or depth. So later on in math, you will be saying length, height, and depth. But for now on, you don't have to worry about that. So now that we just talked about how most flat shapes are determined through triangles, we should talk about the circle. Does anybody have any questions before we go to circles?
No.
Okay. We're having a big connection issue, I'm seeing. Man. Okay. Let's go into circles. So a circle is round. It has no flat sides, so we cannot use triangles for it at this point in time. Later on, you will learn how to look at curves using triangles, but you do not do that now. For now, we have to use equations that describe the perimeter and the area of circles. Now, when you describe circles, you do not say perimeter, or at least in terms of math, you don't. In real life, you may say the perimeter of a circle, but in math, we call it a circumference. Let's start with finding the area. Does anybody remember the formula for the area of a circle?
Pi r2.
Pi r squared. Perfect. Now, r represents the radius. So from the outside of the circle to the center is the radius, and pi describes the circumference I'll just abbreviate it. Circumference over the diameter. And the diameter describes the length through the whole circle through the center. And this expression comes out to an irrational number known as pi. If you remember, we talked about irrational numbers back in the real number system. So pi is a number that cannot be expressed, but pi is not a real number that can be expressed as a regular fraction, but can be expressed as the circumference over the diameter. That comes out to the ratio of pi. So that is how you do circles. Does anybody remember the area of circles? Does anybody remember what the equation for circumference is? Very well. The circumference, we'll write it as C, is equal to 2 pi r. Now we just said that r describes the radius and pi is the circumference over the diameter. Now, if you'll see, the circumference is 2 pi r. It is 2 multiplied by r multiplied by pi. If you remember, we just said the diameter is the length through the whole circle through the radius, and the radius is half of that. So 2 times the radius is the same as saying the diameter, which times pi equals the circumference. So the circumference equation is merely a rewritten expression of the pi equation. So you multiply diameter both sides, and you get the circumference equation. Any questions so far?
No, sir.
Very well. This is essentially what we learned, what we reviewed in terms of equations last class. What I want to do today is double down on the concepts that I'm trying to relate to you through some additional examples that we didn't cover yet and using new shapes. Does anybody know what a trapezoid is? Very well. Let me get the exact definition. So a trapezoid, in its exact definition, is a four-sided shape with one pair of parallel sides. Does anybody know what parallel means?
Straight, sir.
That's a good way of saying it. So parallel lines mean that if you had lines that went on for forever, that if they were parallel, they would never touch each other, because let's say that one line is flat, the other line must be flat too. Good afternoon, Miss Alicia. So parallel lines describe two lines that are of equal direction. So if one line is flat, the other line must be flat. As we may have discussed before, in slope, the slopes must be the same. So if this line were on a graph and it had a slope of 1, this other line must have a slope of 1 as well. Any questions so far?
No, sir.
Very good. Miss Alicia, good afternoon. Are you new? Miss Alicia, I don't quite remember you. Were you in one of our previous classes?
Sorry, sir, my internet was bad.
That's very fine. Miss Alicia, I seem to be having a hard time remembering. Were you in our previous classes?
Yes, sir.
Okay, very good. I'm sorry, I'm very forgetful with names. But
Okay.
Miss Alicia, huh?
It's okay.
Very good. So what we were describing was geometry, and we went over perimeter and area, and we are moving on to describing a new shape called trapezoid. If you do not understand many of the concepts we have described, I will be posting a recording of our last session, which covers all of this. Miss Alicia, I'd like you to stay a little bit longer after the meeting so as to discuss getting you into the WhatsApp group. But for now, please do your best to understand what we're doing. So we went over what parallel lines are, and applying this, we know that a trapezoid has two lines that are parallel. So these would be the lines on the opposite side. So if we have our lines here, let's say these are the parallel lines, that means that a trapezoid is any other, a trapezoid can have lines that point in any other direction. Now I would like to note a square and a rectangle are not trapezoids, because while they are four-sided shapes, a trapezoid must only have one pair of parallel lines, and squares and rectangles each have two sets, because squares and rectangles must have all right angles, and each set of sides must be parallel. So this can be a trapezoid. This can be a trapezoid so long as these lines are parallel, and this can be a trapezoid so long as these lines are parallel. These shapes, trapezoids, are important. You will be using shapes like trapezoids later. You will be using trapezoid later on in calculus in a certain way to understand a certain concept involving curves. Does anybody know? So I want everybody to draw a trapezoid using our definition. So it is a shape with four sides. It must have one set of parallel lines, and the other set of parallel lines cannot be parallel to each other, and it must be a shape. Can anybody draw this for me? I want everybody to draw their own examples of a trapezoid. Any questions? Very good. If you are done, please put so in the chat. If anyone is not familiar, the way you show that two lines are parallel is by drawing arrows inside of the lines like this. Does anybody have any trapezoids?
Yes, sir.
Would you like to share your would you like to share
Yes,
it on your
sir.
screen? Thank you. Mr. Deochan, I believe you drew a cylinder. I'll get to that in just a second. Thank you, Mr. Deo-chan. Miss Anusha. Very good. Would anybody else like to share their trapezoid? Thank you, Miss Anusha. If not, very well. So I guess I'll quickly talk about this. This is a cylinder, and a cylinder. I have a cylinder over. Actually, no. This marker is essentially like a cylinder. It is a little tube enclosed. So it has two lines that are parallel, and on the top and bottom sides, it has circles for their sides. Now, does a cylinder count as a trapezoid? Would anybody like to say if it counts as a trapezoid or not? Very well. So our definition of a trapezoid is that it is a four-sided shape that has one pair of parallel sides. Now, let's talk about four-sided first because it's first in the definition. Oh, Miss Elena. A trapezoid has to be four-sided. Now, if you'll see, a cylinder, it has a top and a bottom, which are circles each. So we can say that this is the top and this is the bottom. Now, we have to figure out what is this. Since we can see that the top and bottom are circles, that means the circumference of these circles must be the sides, and the sides must be the same as the circles across a certain height, such as the height of this marker. Now, if we think of a cylinder like, let's say, a roll of paper towels, when you unroll it, makes a long rectangle of how many towels you use. And this is what happens when you unroll a cylinder. So the sides of these cylinders would be, this is the circumference of the circles, and this would be the height of the cylinder. Any questions so far? Very good. So these are all the sides of a cylinder. So we can see that a cylinder has only three sides. So we know that that is not correct. So the cylinder does not have four sides. Let's look at another thing. So we see that if a trapezoid must be a shape. Does anybody remember the definition of a shape? Okay, so a shape I'll get rid of these. A shape is a 2D, in other words, flat, and it must be closed. Those are the two main factors of a shape. A cylinder is closed because you can see there's technically no openings in the cylinder. So if as I drew it out, there's no holes in this cylinder. If you had a cylinder in real life that had holes, such as a paper towel roll, the paper towel would have holes. But if you were to draw out the paper towel in its true form as a cylinder, as we have here, there are no breaks in the outlines that would indicate that the shape is not closed. Such an example would be if I drew the cylinder so that it was missing this bit of side here. That would be an example of the shape, the form in this instance, not being closed. So we know that a cylinder is a closed shape, or not a closed form. So it's a proper form, so it is closed, but we have to see if it's 2D. 2D means flat. What we mean by flat is that we draw it on a whiteboard such as this, and we get the length and the width, or the base and the height. With a cylinder, there is the length, the depth, and the height. So there are 3 directions that a cylinder points in. Oh, I see there's a chat. Okay. So there are 3 directions to a cylinder. So because there are 3 directions, it is not 2D, nor is it flat. So, or in other words, flat. So that means it is not a shape. If we were to draw a cylinder as it should be on a whiteboard, then we would draw the circle, and the cylinder would have to be sticking out like this. That's what it means to have a 3rd direction. And because a cylinder has 3 directions, it is not flat, and therefore it is not a shape. Now, let's look at the last part. It has to have 1 pair of parallel sides. Now, we can see that if we draw our cylinder model on here, the outline of the cylinder, these lines are parallel. So this is true in a sense. However, it specifies it has to have parallel sides. The only issue is that they must be sides. What we see is that a cylinder is basically a bunch of circles, and there are a bunch of circles stacked on each other, essentially. So kind of like a slinky, if that makes sense. So because a cylinder is essentially a bunch of circles, then that means that it has as many sides horizontally, where we drew the parallel lines, that a circle does. And we know about circles that sides are flat. And because sides are flat and circles are round, that means there are no flat parts to a circle. And because there are no flat parts, there are no sides. So that means there are no sides here. So ultimately, this is not a trapezoid. But I do appreciate the effort you did in trying to use a cylinder. And we managed to go over essentially every single concept about shapes whilst proving that this is not a trapezoid. So I will give you credit for that. Thank you, Mr. Deo-chan. Okay. I am recording. I know for a lot of you there are connection issues, and I do break up every once in a while. So because of this, I would encourage that if you do not understand some things, that you come back to the recording that I will post later. And on WhatsApp, I will be, I am very much open to helping you with concepts you do not understand on WhatsApp privately. So Mrs. Anusha's example of a trapezoid, she has a shape because it is not closed. It is flat, so it counts as a shape. So the shape is true. It is four-sided, 1, 2, 3, 4. So it is four-sided and has to have one pair of parallel sides. So she has sides because they're flat parts and they are parallel. And it is only these pair of parallel sides, that's only this pair of sides that are parallel. So that means this is a trapezoid. Very good. Thank you, Ms. Anusha. So using Ms. Anusha's trapezoid, we can talk about how we look at trapezoids. Now, when it comes to perimeter of a trapezoid, it is the same as usual. We add up all the sides. I would like to note that none of these sides are equal. This does not have to be true in all trapezoids. Right? Actually, no, I lied. Yeah. So this is true actually in all trapezoids. Sorry. Isn't true. Because since only one pair of lines are parallel, then that means these lines can never be the same. The two parallel lines can never be the same. Because if you were to keep them like this, they would have to each have sides that go down, which would make it a square, which is not a trapezoid, or they would have to go in different ways, which would cause for the bases not to be equal. This is a shape whereas the sides would be equal that are parallel, but this is not a trapezoid because both sets of lines are parallel. We'll get to this later. But I'm simply just saying that this is a trapezoid and not all none of the sides are the same, so the perimeter would have to be all four of the sides added up. Now, as for the area, we have to look at this trapezoid in a specific way. So here, I'm rotating. Nah, I don't need to. I'll move Miss Anusha's trapezoid over here. As we can see, this trapezoid has flat sides. And what we know about flat sides, as I have said earlier, when we have flat sides, we can measure every flat side in every flat sided shape in terms of triangles. So we need to break down this trapezoid into triangles. Are there any questions so far?
No, sir.
Very good. Because if there's anything that anybody does not understand currently or is confused, I would be more than happy to re-explain it. Very good. So, all flat shapes with sides, as this indicates, can be broken down into triangles. Now what we can see, starting off, is we should think about what shapes we can break this down into using triangles. So we have rectangles and we have triangles, and these comprise all flat-sided shapes. Whether or not it's squares, and triangles can be turned into hexagons and so forth. So if we think about this in terms of rectangles and triangles, what we know about rectangles is that it has two sets of parallel sides. So one way we can try and break this trapezoid down is we can make it into a rectangle because it has four sides. And if we make it into a rectangle, then we can break down the rectangle into triangles. That is generally how you should approach flat-sided objects. So let's take a line, let's say this line, and let's try and break it down. So if we were to simply draw a rectangle like this, we would be left with a trapezoid. And because we're trying to break down a trapezoid, this doesn't do us any good. So what we want to do to break it down is to create the side at the other side in the non-perpendicular line. And what this does is that it makes it so that there is no trapezoids between the one on the bottom and to the triangle on the top, if that makes sense. So we are trying to reduce the amount of sides inside of the trapezoid so that we only have a rectangle and a triangle. And we do that by reducing this side to nothing while we keep this side. So what it ends up looking like is here, where we have a rectangle and a triangle on top. Any questions so far?
No,
No,
sir.
Very well. So let me draw this a little neater. Yikes. Let's say we do the other thing, but upside down just to make it look better. So we took this side and we brought a side down here so that we made this bottom part a triangle and this top part a rectangle. So now it looks good. If we are trying to find the area and we have broken the trapezoid down into a triangle and a rectangle, can anybody tell me what either the area of a rectangle or a triangle is?
The area of a rectangle is half base times height, and the area of a rectangle is length times width.
I believe, unless I misheard you correctly, you accidentally said rectangle twice. I believe you meant triangle is 1/2 length times height. Yeah, and a rectangle is 1/2 length times width. In this instance, I want to say length times height because both height and width in this instance would refer to up and down. Or, whoops, I meant to say just length times height. So, I'm very sorry. If this describes height, and this describes, I'm going to erase the definition for now. If this describes height and this describes length, does anybody know or recognize anything about our two shapes? Do they share any measurements? Let's label our rectangle. Yes, Ariel, I will be doing a YouTube channel. I will send the link in the WhatsApp. So in our rectangle, this is length, this is length, this is height, and this is height. Do the triangle and the rectangle share any sides?
Yes.
Okay, which side?
The length.
Okay, the length. So we can see that the lengths will be the same. So we should keep this in mind. Thanks. Now, because of the way we drew it, the length is the same as opposed to the height. Normally, we would have height be the same, but this does not matter at all. So we should remember that it is length and height. I mean, length, it is the lengths that are the same. So we know that the area will be equal to the length of the area of the trapezoid will be equal to the area of this rectangle and the area of this triangle. So let's write it out. Our area is equal to the area of a rectangle, which is length times height. For the purpose of what we have here, because our heights are different, let's say that this one is height 1 and this one is height 2. This is an important differentiation. So height 1 would describe the whole height, and height 2 would describe the height of the rectangle. So area of the rectangle, length times height 2, and then we add to the area the length, the area of the triangle, whereas we would use 1/2 length, and we need to figure out what this height is. Because we don't know what this height is, we'll have to say that this is height 3. And let's make a distinction right now, because we see that this is height 3 to describe our triangle. We can say that height 3, as we see in our model, is just the height of this little triangle. It is the same as the height of the whole shape minus the height of the rectangle, because we see here the height of the rectangle and the height of the triangle. So height 3 is height 1 minus height 2. Any questions so far?
No, sir.
Okay. So now we're going to be doing a little bit of longer math. So as we have it, area is equal to length times height 2 plus 1/2 of length times height 3. Because we can see that height 3 is equal to height 1 minus height 2. By the way, you don't have to write notes for this, because we're just proving it if you were writing notes. Because height 3 is equal to height 1 minus height 2, we can rewrite our equation as L times height 1 minus height 2. So if we do the math out, we get length times height plus 1/2, well, length times height 2, plus 1/2 length times height 1 minus 1/2 length times height 2. Now, if you remember like terms, it says that we cannot subtract this from this, we cannot subtract this from this because they are different variables because of the heights. But because this uses length and height too, and this uses length and height too, we can subtract this from this. So since this is 1 times length times height 2, and this is 1/2 length times height 2, what's 1 minus 1/2? Anyone?
Half.
Exactly. So if we subtract this from this side, we get our area to be 1/2 length times height 2 plus 1/2 length times height 1. And this describes the area of a trapezoid because now we have the length of the trapezoid, and for each of the parallel sides, we're using the both sides, side 1 and 2, so that we come out to this equation, which if we can see a common factor, we can simplify this equation out to be 1/2 length times height 1 plus height 2. In a normal description, we write this as area is equal to 1/2 height because people usually like to keep the height constant instead of the length. Height times base 1 plus base 2, where this describes the sides. And the height is what remains constant. Does anybody not understand how we got to this from this? Okay. So this equation is the result of adding the two areas of the triangle and the rectangle that we saw here by splitting it up into triangles and rectangles. And we simplified out the equation to come to this simple one. This is the important equation that describes a trapezoid as the area is equal to 1/2 height times adding both bases together. So in how we would normally draw it in math, this would be Miss Anusha's trapezoid, and the height would be the length as we did it, and we would label this as base 1 and base 2. And we would apply this equation to find the area of this trapezoid. Any questions?
No, sir.
Okay. Very good. So we won't need these notes anymore from here on out. We will just need this equation. So it is 2:10. I would like to offer a 5-minute break until 2:16. Anyone? Yes or no?
Yes, sir.
Yes, sir.
Sounds good. We will come back at 2:16. Everyone there? I'll wait a minute or two. Is everyone there now? I can't tell if you guys are there. Either put in the chat.
Yes, sir.
Okay. Is anyone else here? You can put in the chat, maybe. Okay. That sounds good. So, does anybody have any issues or doesn't understand something about what we said so far about trapezoids? Okay, I'm just going to assume you guys understand pretty well what we were saying here. So let's look at the equation for a little bit. Now, we can look at definitions and such to tell us, we can look at definitions and look at the shape to understand some information about it, but it's very useful to look at the area equation to learn more about the trapezoid. The fact that a trapezoid is just a rectangle and a triangle makes it very useful later on for what we would do. Let's say we had a trapezoid whose height was 1. The first side was 2, and the second side is 3. Don't worry about measurements for now. Can anyone tell me what would be the area of a trapezoid that has this information? Just call it out if you get it. Anyone? In the area equation, you have 1/2 height times base 1 plus base 2. And here you have height, base 1, and base 2 here. Can anybody tell me what the area is? So since the area is equal to this, we can take the values that we have here and plug it into our equation. So area equals 1/2 times height is 1, and multiplied by base 1 is 2 plus base 2 is 3. So we do out our equation. It is 1/2 times 1, which is anything times 1 is itself. So 1/2 times 2 plus 3, which is 5. So our area is equal to 1/2 of 5. Did anybody get anything different? Okay. So our area is 1/2 of 5. So let's remember this for right now. Let's draw our imaginary trapezoid. We'll erase this for now. Draw our trapezoid. So our height is, we said, was 1. Base 1 is 2, and base 2 is 3. Mr. Landon's having connection issues. Okay. So here's our trapezoid. Our height is 1, base 1 is 2, and base 2 is 3. This comes out to an area of 1/2 of 5. Now let's think about the what would happen to the trapezoid if we changed the area a little, or what happened to the area of the trapezoid if we changed some of the measurements a little. If we were to half the height so that instead of 1, as we have here, it is 1/2, that means the equation would change. Since height is multiplied by everything, if we half the height, then that means our answer is halved. So if height is 1/2, area is halved. So the new area would be 5/2 divided by 2. So 1/2 divided by another 1/2, or no, 1/2 of a 1/2 is 1/4. So the answer would be 5/4 instead of 5/2. Where do I have space? Okay, so 2, 3, and 1. So this area we found would have been 5/2. This new trapezoid, when we halve the height, is 5/4. Now, let's think about what we would have to do to make this trapezoid, have the same area as this one without changing the height again. So if we were to keep this trapezoid at a height of 1/2, we have in our equation height here. If we cannot change this height, what are we left that we can change? Anyone? Miss Anusha, you can't hear me that well. So, by having our height, when it was 1 before, if we changed it to 1/2, we said that the area in total would be halved, so the new area would be 5/4 instead of 5/2. Now that the height is 1/2, can we make the area of the new trapezoid? Can we make the area of the new trapezoid, which is now 5/4, equal to the area of 5/2 from our previous trapezoid by changing any of the other measurements of the trapezoid? Miss Ariel, are you there? Miss Anusha, are you there? Goodness. Okay, Miss Anusha. What do we have? What do we have in our trapezoid equation? So we have the height. What else do we have?
The base.
Very good. We have bases 1 and 2. So in our equation, when we made the height half, it caused the whole area to half. So if we can change the bases, then could we increase the area so that it would be equal to the first trapezoid?
Are you breaking up?
Sorry. So if we could, if we use the height and we change the height so that we cut the area in half, can we change the base measurements to make the area 5/2 again?
I'm not sure.
Okay. So what's the opposite of a half?
A whole. 0.5.
So if we have a whole, so we have our original area, and our new area is half of, our new area is half of A1, our original area. How could we change the new area so that it'll be equal to the first area again? Yikes. Yeah. Okay, so if we divide the original area by 2 to get the new area, what would we have to do to the new area to make it equal to the first area again?
Multiply by 2.
There we go. So we have to double the second area. So the original area would be equal to 2 times the new area. So we'd have to take our area and multiply it by 2. So we'd have to double this equation. But we don't want to change the height. So we want to double the equation by not changing the height. We said that aside from the height, we have base 1 and base 2. So if we increase base 1 and base 2 by enough, then we can double the area. Does that make sense so far?
Yes, sir.
Okay. Let's erase this a little. So originally, we did our equation. We substituted our values in. So in this, we had area equals 1/2. Our new height is 1/2. And our bases, we don't know, because we'd have to change the bases by however much. Sorry. The old area, we did the calculations out, and over here we had 1 times the bases added together, which was 2 plus 3, which came out to 5, and 1/2 times 5. So 1/2 times 5 was our old area. So let's back up a little bit, and we can take our equation and we can say, if we don't know what the new basis will be, let's pretend that we didn't have the bases in the old equation. So let's say we just had base 1 and base 2. If we set the equations equal to each other as we had here, we had before 1/2. In our new equation, our height is 1/2. Is equal to 1/2 of, because we said before that that half of the first area is equal to the second area. 1/2 times our height was 1, and we don't know what our base 1 and base 2 is. Let's just say we don't know. While we don't know what our while we can pretend that we don't know what our original base 1 and base 2 were, what we will say is that base 1 plus base 2 was equal to 5. So let's pretend this was 5. I need to make space. So when we simplify this equation, let's say that instead of having our unknown bases, we'll just say it was x, as if it was a variable, and we'll say that our original basis was x1, our new bases were x2. We know that x1 is equal to 5. So let's write up here, take our notes, that base 1 plus base 2 is equal to x, and x is equal to 5. And then x2 would be basically the unknown bases. So if we do out our equation, as we have, we would we would simplify our equation. So we would take away the 1/2 from here here, right? I did something wrong. I didn't know I didn't. We said that our if we factor this out, that since 1/2 of the original area was equal to the new area, we prove it by showing that the original area, which came out to 1/2 times 5, we wrote down here so that it was 1/2 times 1/2 times 1 times x, which is our bases, was equal to what we wrote here, 1/2 times our height of 1/2 times x2. We could factor out these halves, and we could see, if we ignore this half for a second, that the original x, if we said that that the new area is half height, then that means the new base must be God, what is going on? I'm sorry, guys. I'm having a bit of a blank moment right now. Okay, yeah. So if we ignore this 1/2 for a second, we would see that from area of A1 and A2, that because we did half of the height, we would say, ignoring this area, that the base, the first base, would be the same as half of the second base, because we ignore this. It's because that we added this half here that we said that half of the first base is equal to half of the second base. That's how we made the equations equal. But by seeing that because we took the original equations, that our area here with the bases x1 is equal to half of the bases in x2 in area 2, we can solve this equation for x2 and say that x2 is equal to 2 times x1. Does anybody have any questions right now?
No, sir.
No, sir.
I'm trying to come up with a better way of explaining it than this. So what this is saying is that, let's take this out. What this is saying is that, yikes. Half of area 1 is equal to area 2. That's what we found out with our equations. We had the original equation, which was half of 5, and our new equation, which was a quarter of 5. So we know that area 1 is equal to 2 times area 2, because we took half of area 1. So if we simply said that area 1 is equal to 2 area 2, and we did out our equations again, so we wrote this all over again. If we were to keep the height the same, and we were to only change the bases, then it would be saying that if you were to eliminate the heights from both sides, then it would come out to the first bases being half as much as the second bases. So what I'm trying to get at is that because area 1 equaled 5 over 2 and area 2 equaled 5 over 4, in our equation, because we have our height, in order to make the area equal, so what I'm saying is that in order to make the area equal to balance the taking half from the height, we want to double what the bases come out to be, because if we half the height but we double the base, then the area will come out to be the same. That's what I'm trying to get at. So if in our original equation, B1 equaled 2 and B2 equaled 3, then if we have the height, we can get the same area by just doubling what the bases together equal. So that means that we could either say 4 plus 6, so that it is 10. Did anybody need to ask something?
Okay, you can mute.
I'm sorry. So what I'm saying here is that if we were to keep the area the same by using the height now that we halved it, that means the base 1 plus base 2 must be doubled. So that means we can have, we can change the bases by doubling them so that it is 4 plus 6, and that would come out to be 5 over 2. But we could also change the bases so that it is, for example, 3 plus 7. What I'm trying to say is that we don't need to, the bases don't need to be any one thing, that you can change around what each base equals and keep the area the same. Does that make sense?
Yes, sir.
Okay. Is there any way I can explain? Does anybody not understand it? So we have the trapezoid here, height of 1, base 1 of 2, and base 2 of 3. This would have the same area as this. So these two would have the same area because of how we did at the math. This plus this times this is the same as this plus this times this. And also that this also has the same area. All right. It is 2:47. Any questions so far?
No, sir.
No,
Okay.
sir.
So if we have the height, that means base 1 plus base 2 must be doubled. If we think about it the other way, if base 1 and base 2 were to come out to half of what it did originally, that would mean that we have to double the height. So that means, let's say we had 3 over 2 and 2 over 2, and we had 2 here. This would, this would also come out to 5 over 2. So this would also have the same area as these. This is what I'm trying to get at. Now, aside from this, we talked about changing the height and changing the bases, but let's think about what would happen if we were to change an individual base. So let's stay with our original trapezoid 1, 2, 3. If we were to change the height to 0, what would the area of the whole trapezoid be? Does anyone know? So this would be our new trapezoid. Does anybody know what the area of this trapezoid would be? Because its side is 0. Perhaps Mr. Aryan.
Sir, I didn't hear you. Can you please repeat the question?
Very well. If we change the height so that the height was 0, like in this trapezoid, if this side was 0, this height, would you know what the new area would be?
So I'm not sure, but I think yes, there is a way you can know.
Okay, so if the height of the trapezoid was 0, that means that it would be completely smushed flat. So this would be what the trapezoid now looks like, because this height is 0. And this just becomes a line, and the line doesn't have area. If you see in the equation for the trapezoid, area equals 1/2 height times the bases. If you make the height 0 in the equation, then the whole equation will become 0 because the 0 distributes to the base 1 and 2. So the new area of this would be 0. Any questions?
No,
Okay. Good. So if we took the height and we made it 0, that means the shape would now look like this. What would happen if we took base 1, which is 2 right now, And instead of the height, we made base 1, 0. So the new trapezoid would look like this. Can anybody tell me, would the new area be 0? Does anyone at least want to guess? Miss Anusha, when we said that the height was 0, we did make the area 0. That's what we found. So in that case, when the side was 0, the area became 0. However, now that we're making one of the bases a 0, I'm wondering if it's any different. So Miss Anusha, if you think it's 0, just say it's 0. So if we use Miss Anusha's justification, how can we have a side of 0 if it has no measurement? It's true. A side of 0 is doesn't exist because a side, if as we said before, a side has to be a flat surface. It has to be a line, and you can't have a line that is 0 length because then it would just be a dot. So then there would be no side. So Miss Anusha's remark is correct. The new shape would not have a side where B1 is, or the first base is. But I would like to note that the height described both this side and, in a sense, this side. Because when you make the height 0, you smush the entire thing. But as we wrote here, base 1 is independent of base 2. Because when we showed before, we can change the area, we can change the sides of base 1 and 2, and they wouldn't affect each other. It would just change the area. So like how we have this, we could make it like this. So the height is still 1, the new base 2 is 4, and the original base 1 stays at 2. Even though we changed base 2, it didn't change what base 1 was. So if we think about the new shape, we know that the height will stay 1, and we know that the base 2 will stay 3, but we know that we do not have a side. We have a point. Because that's what would happen if we made the base 0. But if we look at our area equation, if we made the base 0, then we would cut out the base. So if we cut out the base from this equation because we put in 0 for it, the area would be 1/2 height times base 2. What we notice here is that the area did not become 0 because we still have our height and our base. Does anybody see if this equation looks similar to any other equations you know?
Yes, sir. Finding the sides of a triangle.
Finding the area of a triangle, very good. Because we made base 1 0, the equation now became area equals 1/2 height times base 2, which is the same as the area of a triangle. Which is 1/2 base times height. So what this means is that if you take a trapezoid and you make not the height, if you make one of the bases 0, then that means that the trapezoid becomes a triangle. So Miss Anusha was completely correct when she noted that you can't have a side if the measurement is 0. So we don't have a side anymore. And because we don't have a side, we have a point here instead. What happened is that we took away a side, so that means the shape only has 3 sides, which means it became a triangle. Does anybody have any questions?
No, sir.
Okay. So I'm going to assume that you don't have any questions. So for example, let's say that you had a trapezoid like this. You would describe it as with this equation to find the area. But because 2 sides are parallel and the other sides are not, that means that if these lines aren't parallel, that eventually they'll intersect. So if we draw this going on for forever and we draw this one going on for forever, we can see that since the lines eventually intersect, we can make a triangle out of this. So what this means is that a trapezoid is simply a triangle with the tip cut off. So once again, it all comes back to triangles. And that's why a trapezoid is important in a sense. If you had a trapezoid like this one, where one of the sides was not curved, because it is not, if it's going straight up, not curved. If you had a side like this, where it only goes straight up, it is still not parallel to this side. So, if we draw out our trapezoid, that means that we can draw this line going for forever, and we can draw this line, and we see that we have a right triangle. So that's what describes, that's what our trapezoids are describing in a sense. They are just one big triangle with the top cut off. And that's why the trapezoid equation looks like the triangle equation. So it is 3 o'clock and we went over plenty today, and you didn't, I don't think you would have understood everything because of connection issues. So we will leave it all for here. It is 3 o'clock. Does anybody have anything they wanted to say before we end class?
Sir, is it possible that you could share the recording of the classes on WhatsApp?
Yes, yes. So up until now, I've been having a lot of difficulty with recordings because first off, the recordings kept on getting deleted. And second of all, when I finally got recordings, you can't send them over WhatsApp because there's a file limit, and Zoom recordings take up a lot of space. So what I ended up doing is that I actually created a YouTube channel that I'm going to upload that I'm uploading the recordings on. Starting from the recording that we took last week. So if you weren't here from last week to understood some of the things that we went over, you can look at that recording, which I'll put up later, and I will be putting the recording of this one up too. And it says here that we're recording, so it better save. So later on today, I will put the channel in the WhatsApp chat, and you can follow the channel to YouTube, and that's where the recordings will be. Everybody get it?
Yes, sir.
Yes, sir.
Okay, so aside from Mrs. Oh, she left. So all of you can,
Excuse me, sir.
yes?
I am with dear Chan here because my tablet is not working.
Mhm.
Yes, I'm with Gigi.
I'm sorry, I can't understand you.
Sir, I'm with dear Chan here
Yes,
because my tablet is not working.
yes,
Okay.
very, very good. Okay. So as long as every one of you is in the group chat, unfortunately, Mrs. Before left. All of you can go now. Have a great weekend. Stay safe.
Bye, sir.
Bye,
Bye,
everyone.
son.
Thank you very much.
Bye.
Bye.
Have a good day.
You too. Thank you very much. Did you need anything, Mr. Deo-chan?
G.
Bye.
Goodbye,